Hi, everyone. It's wonderful to be here. And as I was discussing, what would be most interesting for the audience of Hello Tomorrow to hear about, I was like, well, why don't I speak about AI and ML, of course, given obviously XTX Markets positioning as well. And the organizers went like, oh yeah, actually we don't have any sessions dedicated to it. And I kind of laughed and smiled at it because probably every single session has something around AI in it, hopefully. My name is Gabriele Papievyte. I am originally actually Lithuanian, from Lithuania, Baltic states. We're celebrating Independence Day this week, which is very important as in the current climate. So a little fun fact there. I'm a technology optimist and AI enthusiast, I like to think. And I lead XTX Ventures at XTX Markets. We're a large algorithmic market maker, deploying machine learning algorithms into financial markets. And I lead specifically our AI fund. We invest in edge machine learning technologies. And some of our portfolio includes Grok, Anthropic, Gladia here in Paris, and many other AI success stories, some known and some yet unknown. So what I thought would be interesting today to go through is understand a little bit what have we done already with machine learning specifically across a few key areas today, and what are still some scientific breakthroughs that we at least expect to back this year and beyond. So specifically, I thought it would be interesting to touch upon healthcare environments and advanced computing, because apparently, another fun fact, 75% of our conference attendees are within these sectors as well. So as our core business is machine learning, we tend to back specifically those technologies. And often, we speak about AI and ML, but we very rarely hear people speaking about what is actually the technology or method of machine learning that's being used on a specific use case. So if there's one thing that I want you to take from this, is being able to speak a little about an extra deep intelligently about machine learning and AI in the space, and that's what we strive at XTX. So let's start a bit with, spend a few minutes on healthcare, which we are great backers of as well. Overall, I'd like to make the case that healthcare, a bit differently from climate tech and compute, has actually had and seen a lot of funding, a lot of advanced algorithms being used, and lots of data not only used, but also abused in the space. And this is mostly due to, obviously, large pharma involvement and plenty of big healthcare operations, hospitals investing in the space and solving one of the biggest challenges in the space as well. When I wrote actually my very first healthcare thesis now 5 years ago as an investor, the key outcome was this. We are collecting loads of data in the space, as you all know, right? In laboratories, GP offices, on your devices, in your iPhone. But not that many actually outcomes has been driven 5 to, let's say, 7 years ago. We've been collecting a lot of data, not as much real outcomes. What changed specifically, and we like to believe with also our involvement and our investment in machine learning and in the space, in the healthcare particularly, is that those outcomes have become stronger. So this is the case I wanted to make. Today, for instance, we have CNNs, which are convolutional neural networks, that are type of neural network that learn features by itself. These neural networks are being used to scan MRIs, CT scans, as well as X-rays. And those coupled with DICOM image processing that connects and enables interoperability between software and devices has helped us become extremely that much more accurate. So today, for instance, again, connecting this use case with the technology, we are determining breast cancer 99% accuracy, right? Which is very real outcome of specific machine learning method applied in healthcare. Also, ML-identified cancerous nodules are happening now 1 year earlier on average with 94% sensitivity, which is another real outcome in the space. Some other techniques, again, just to mention, we see gradient boosting and time series analytics applied for early detection for diabetes and cardiovascular disease, which means that we're able to detect sepsis hours earlier, and also stroke diagnostic went from 150 minutes to 45 minutes. What that means, again, very real, in very real terms, someone post-stroke, that helps us reduce the disability cases just by that time reduction. Another high-value area that, again, already has been done before going into the kind of scientific breakthroughs is that by using the Bayesian networks and reinforcement learning from the drug design technologies, we are able to predict genetic variation impact on specific drug structures. What that means is that our adverse effects predictions become much, much more accurate. What that again means is that we're getting the drugs to the market that much faster. Vaccines, certain medicines that are extremely crucial. So all of this just to make the point that machine learning has established its position. These specific methods have already driven real outcomes, and most importantly, hospitals are saving tens of billions, right, every year, as well as pharma companies, hundreds of billions in drug development process. This is more or less known, right? This is not real. This is more or less kind of something that we already hear on the news. And a lot has been done in terms of, reducing human errors and just speeding everything up in general. But we do believe it's still at start. So that's what, for me, what excites me the most is that one area that we're in particular right now, this year especially, we're looking to back is how can we integrate multiple data types in healthcare? That means combining imaging, genomics, like text and lab tests, as well as patient records. Because existing ML systems, just like example with breast cancer, actually tend to focus on a single modality. And it's very difficult, but a perfect use case for machine learning to solve going forward. With that, we would be able to drive much more real outcomes by analyzing both imaging, but also genetic modular data, but also, again, your Apple Watch data, which requires much, much more advanced machine learning modules, and that's something what we're investing in this year. Another area that I'm particularly really excited about is creating digital twins. So imagine a virtual replica of individual patient to stimulate your own biology. So a patient with cancer would be able to inject different types of chemotherapies and see the impact of it going forward and be able to choose much, much more accurately. Again, this represents immense computational and biological complexities, but this is something what we see specific, again, machine learning methods being applied already. Another area that we already backed is actually rare diseases. That requires immense data sets. However, these data sets often prove challenging due to obviously limited prevalency of these diseases. And one of our actually own portfolio company, Curate in Cambridge, is doing exactly that. Because with specific unsupervised learning, or more specifically self-supervised algorithms, they are able to detect unique patterns in these without extensive prior knowledge and labeled data sets. Lastly, what's, again, very exciting case is being able to map the whole brain imaging and target specific interventions to unravel complex neurological disorders. We're pretty much still in the dark with Alzheimer's and Parkinson's, so that's something that we're looking to back as well. So holistic integration, adaptive decision maker, and of course quantum-assisted biology are the key scientific breakthroughs that we expect this year. And surely regulation will try to slow it down, but the outcome is so strong and important for us that we're sure to get there. So a few minutes on climate tech. While the space has also benefited from increased concern and obviously more and more attention, the funding actually hasn't been as strong in the space due to specific cost infrastructure. At XTX Markets, we're one of the largest top 20 carbon credit buyers in the world. So this is specifically important to us too. It has become critical enabling climate tech, renewable energy systems, and again, we have CNNs, convolutional neural networks, being used to analyze satellite images, to monitor ice melt, to monitor snow levels, snow coverage, which are critical to understand rising sea levels. We have, again, Gaussian processes applied in extreme weather prediction, and machine learning really is able to act as a surrogate to reduce these simulations to minutes. And the outcomes are, again, very clear. ML-optimized renewable batteries are improving the storage life by 20, 30, 40%, and flood forecasting models today are able to predict it at 90% accuracy, which is fantastic. But again, similar to healthcare, there's like a very clear parallel because we are going across the machine learning innovation here. And we are on the lookout for multimodal climate models that unify diverse data sets. And here specifically, I'm referring to being able to incorporate atmospheric, oceanographic, and socioeconomic data to predict climate systems with unprecedented accuracy. Again, having Earth-scale digital twin would help us stimulate what we as humans do to the planet and how certain economic policies, environmental policies would impact that in real time, which obviously would allow us for real-time interventions and overall tracking, automatically tracking the whole emission systems. That is a data problem, and that is a perfect use case for ML. And this is what we're looking to back as well this year. Lastly, but not least, compute. And obviously for us, it's a very big topic because at XTX, we're one of the largest users and buyers of GPUs in Europe. Compute infrastructure is clearly key to enable more intelligent computational systems. Objectives such as, optimized hardware design, faster training times, distributed computation systems are absolutely key in order to make use of better AI and apply AI systems globally. We looked at companies and backed companies to date that use Bayesian optimizations again to automate the selection of hyperparameters, of course, and federated learning obviously has enabled us to witness the collaboration between multiple edge devices to be able to run computes on obviously some of even our smartphones. Now, the systems that are now being used also are able to optimize the very hardware that they are running on. And I'm referring here to ASICs, obviously GPUs and TPUs. This means that these ML designed accelerators, again, a few companies within our own portfolio, allow compute hardware today to perform 100 to 1,000 times faster operations on AI-specific workloads. Which obviously, then these innovations within AutoML, federated learning, are all for data centers, cooling technologies, which are all key, pruning, chip design, are all areas that we just cannot imagine the AI future without. So we have already witnessed training acceleration of 10x delta for large models, 50–80% reduction in latency, 40 to 50% reduction in cooling energy, extremely crucial for data centers today to make use of, and 90% reduction in model size requirements, which is pretty impressive. What's next is quite deep tech. We wait and we constantly monitor people developing ability to integrate symbolic reasoning, which are rule-based systems within deep learning to solve compute-intensive problems that would improve both reasoning and perception. That would enable a crucial advance for domains like robotics, I'm sure you hear every day, which is exactly what's still missing today, automating theorem proving as well, and program synthesis. Another unrealized goal yet is deploying an operating system co-designed entirely by ML that is able itself continuously evolve with world applications, but also without any manual intervention. So imagine having a GPU that's and a hardware-aware ML system, how much of the resources it needs. This is something we expect and we are aware certain chip teams are working on this year in Europe and US. That would obviously enable massive reductions in both compute and memory usage. Therefore, especially in compute, there remain key scientific gaps such as zero energy model, true neural symbolic systems, and much more efficient spare architectures. These bottlenecks we expect to push ML and compute much further and expand into entirely new categories of intelligence, sustainability, and of course, scale. We are very excited about ML. I'm very excited about ML. There's been a lot that has been done in more specific technical methods to date, and we've proven that it works, and we've proven that we really can't do without it across our core infrastructures and core industries and our everyday lives. This is something that we'll continue to back, and if anyone is building in this space or applying any machine learning methods that I mentioned, please do reach out. Thanks so much.